Hi, today we talk about Bohr's atomic model. In the last video, we talked about the atomic model of Rutherford. According to Rutherford, there are electrons rotating around the nucleus. But if electrons are rotating around the nucleus with no stopping, then they must lose energy and collapse into the nucleus, and the atom would be unstable. Then came Bohr. He stated that when electrons orbit the nucleus, a centrifugal force arises to compensate the attraction force between the nucleus and the electrons. Bohr added some hypotheses to those of Rutherford. Electrons rotate around the nucleus with a very high speed without losing energy. Electrons orbit the nucleus in a specific energy level. Electrons cannot be found between these energy levels. More of Bohr's hypothesis. Each electron has an amount of energy. This energy depends on the distance between the electron and the nucleus. And because the energy of each energy level depends on the distance between the energy level and the nucleus, the bigger the distance, the higher the energy of the energy level, and the energy of the electron, of course. Examine the picture. The further the energy level is away from the nucleus, the less the distance between the energy levels. Each energy level is expressed by a whole number that's called a quantum number, from 1 to 7, since we have 7 energy levels. But there is no 1.5 or energy level with number 6.75. It's only whole numbers. Electrons can only be found in their definite energy levels, but not in between these levels. But does the electron spend all its life in one energy level? No. If the electron gained or lost an amount of energy that equals the difference between two energy levels, the electron starts to move immediately to another energy level, either a higher energy level or a lower energy level. It depends if the electron is gaining or losing energy. I think you need more details. First, we need to know that the lowest energy level that the electron can have in the atom is called the ground state. When an electron gains energy in the form of a photon, and the energy of this photon equals the difference in energy between the electron's energy level, ground state, and another energy level, then the electron moves to this another energy level, a higher energy level. In this case, the electron is called excited. But the excited electron doesn't stay in the higher energy level forever. The electron loses this gained energy and returns to its energy level, its ground state. The word quantum is the amount of energy lost or gained by the electron. There is no half quantum or 1.5 quantum. One quantum equals the difference between any two energy levels. Bohr also concluded that the difference in energy between any two energy levels is not equal. The energy gap decreases as we move further away from the nucleus. But why? When the difference between two energy levels increases, the gap between these two levels also increases. And when the difference between two energy levels decreases, the gap between these two levels also decreases. Remember, it's impossible for an electron to move from one energy level to another if the energy gained or emitted is less than the difference between the two energy levels. Now, let us talk about Bohr's success. He succeeded in explaining the hydrogen atom spectrum. There will be a video about this later. Another thing Bohr did right was introducing the idea of quantized energy state of the electron, the idea of the quantum. But what did Bohr didn't get right? First, all his work was based on the hydrogen atom, but he failed in explaining the spectrum of any atom that contains more than one electron. Second, Bohr considered the electron as a negative charge only. He didn't consider that the electron may also have wave properties. One of Bohr's hypotheses, he thought it's possible to determine both the location and the speed of the electron at any given time. This hypothesis was proven to be wrong later. Bohr's equation described the motion of the electron in a circular planar orbit, just as the motion of the planets around the sun. This means that the atom is a two-dimensional particle. Later, it was proven that the atom is a three-dimensional particle. Electrons only exist in their energy levels, and they cannot be found in areas between these levels. That's what he thought. Later, this point was also proven wrong. That's it for today. I hope you enjoyed. See you later.